Então vou pôr a
Perfecto,
gravar. Está a gravar
perfecto.
na nuvem. Assim és mais fácil,
Vale.
mais sencillo.
Mais fácil.
Ok.
Nuno, o Oscar entrou à sala.
Ok. So we have a minute to begin. I start with some apologizes because my computer is a little bit old and the fans are always super on. So maybe you can listen a little bit of noise, background noise, but I think that it's not very bad. So let's start. Thanks for your presence here this afternoon. Pepe is here with us too. And I'm Nuno from Portugal. I'm an instructor of Global Audio Solutions. And this afternoon, the idea is makes an overview about Rita 2.4, explain how it works, how uh, was the idea behind Rita, uh, and so let's start. I will share my screen. I don't know if you are older users of Rita, Rita 2.2 or 2.3, but Rita 2.4 is very different in aspect and is the first commercial product of Global Audio Solutions. So let me just pick it to another place. So let's start. I have a little setup here with a speaker, and we can make some electrical measurements too. So what is the idea behind Rita? The idea is just take the measurements, take the data, think, and then process and apply it on a real world. So the idea behind Rita is not always making noise, not always bother some people around us. So for that reason, we, and other reasons too, we choose the sweep as our major excitement noise. So Rita is built thinking in sweep and in the convolution theory. So we pick a measurement with a sweep with this type of signal. We convolute the signal with the inverse, and we get our result. So starting, you can use the sweep, that is the principal excitement noise, but you can use, if you want, pink noise, or in this version, external noise. So you can use external to make measurements during your show, for example, or use another type of noise like music to make measurements. So um, it's the possibilities that you have on Rita. So you just have to choose the time of your noise. Okay. So Rita is not, the idea of Rita is not a continuous FFT analyzer. So the idea is work, let's say, virtually or offline, but you can take decisions. So this is the aspect of Rita. I don't know if everyone have this version of Rita 2.4. I think so. So probably you are familiarized with that. And if you have any questions, you can interrupt, pick your microphone, turn on your microphone, and talk and ask whatever you want. If you have some sort of questions, you can make it with no problem.
I'm ready for you. Morning, bro. Hola, Nuno.
Hola.
Can you hear me?
Yes.
Amigo, I understand how to use an analyzer, but this is the first time I encountered an analyzer. For example, I can see the sweep, the next number 2 on the right.
Yes.
I don't know what, if you just, when you ever go through your explanation, if you say these 2 is for this one is for this, I'll be able to catch up and don't do stupid questions like, how can I patch it? How can I turn it on?
Yes.
How can I, you know?
Yes, I will pass an overview about the options, what they do, and if you have any questions, you can make it. So starting from the column at the right, we have the option to generate noise, the correspondent volume, the type of signal that I already explained. So you can pick sweep, pink, or another external noise that came from a player, for example, that can be sending from a desk, mixer desk, so whatever you want. Because what Rita do is record that signal, okay? So it can be whatever you want. So here it's the time of the noise, the excitation signal. Here we have the 2 outputs for going to our system and to reference, okay? For example, we have the coherence slider here, so minus coherence or plus coherence, okay? Let's stay at 15. We have FFT size, so you can pick wherever we want, and normally we use on Rita 64 FPPOs. It's the same on other analyzer like multi-time window is the same. We are picking 64 sort of points of signal for octave. Okay, you can smooth like in other analyzers, and we have 8 engines. Okay, so it's important to understand what is the engines. The engines in Rita are the places where that we use to make the measurements, okay? And these 8 engines are linked with 8 DSPs at the bottom. So at the bottom, we have on the first tab, DSP1, we have the first 4 DSPs. And in DSP2, we have 5, 6, 7, and 8. Okay, and the 8 engines are linked with 8 DSPs. So if we make a measurement on engine 1, that result will appear on DSP number 1, and so on and so on. So they are always linked. So for example, if I turn it on, okay, if my reference is my input 2 and my measurement is number 1, okay, I turn it on. And when I choose, for example, pink of 2 seconds, I can generate. And the result will appear on DSP number 1. Okay. So I can, for example, turn off number 1, turn off number 1, turn on number 2, and I will choose, for example, pink noise of 2 seconds. So when I generate, the engine 2 result will appear on DSP number 2. Okay. So we turn on what we want to use, what engine we want to use. For example, if I have 2 microphones, okay, I can turn it on both. So number 1, number 2, and make one sweep and take the results of 2 microphones, or 3 or 4 or 8. So we have 8 engines that will put their results directly into the corresponding DSP. Okay, this is the first important thing. If you turn it on an engine, it will overwrite what you have on the corresponding DSP. Okay, this is important. So if I have already a measurement on DSP number 1 and I want to make another one, or I have to save first the DSP, or I have to choose another engine to make the measurement. Okay, this is the way that it works.
I have questions. Should we come
Yes.
back or should I interrupt?
No, please interrupt.
Okay, let's do question. How do I make this on time? How can I time delay? You know what I'm saying? How can I
Yes.
put it on time? That's
Like
1, 2.
find the synchronize.
Find delay. Find
Okay.
delay.
Yes.
And before I want to keep going in my engine because I only have 1 microphone and I need to save this. I need to take a
Yes.
picture. I need to do a spacebar thing.
So
okay,
let's imagine that that idea. In RITA 2.2 and 2.3, okay, we don't need a reference signal. So we pick just one time a loop back, okay, as in other FFT analyzers, and we calculate the latency of our system, okay, of my computer, my sound card, my operating system, okay, is my latency, and that latency is fixed. If you don't change your PC, your sound card, this latency is fixed. So in RITA 2.2 and 2.3, we calculate that latency and we can take it off that reference. And for example, in a sound card with 2 channels, use both inputs for 2 microphones, okay? Because they know the internal latency of my system. And my reference is internal. So my reference is inside of the computer. So we start having problems with Windows. So the latency is not consistent. So sometimes in some updates of Windows, everything works fine. Then we discover that just with ASIO drivers, it works okay. And so we use ASIO drivers and sound cards with ASIO drivers, no problem. But then since I think 3 or 4 updates behind, that latency goes away. So always changes. So we can't use an internal reference, okay? So in Rita 2.4, for the first time, we are using a reference channel, okay? But that reference channel is just for syncing, for time, okay? The is not reading frequency of that reference channel, okay? The reference continues being internal, okay? So the reference is just to see how is our latency. In a Mac, we don't have problems, so it's essentially for Windows users. So if now my latency of my system is 10 and next measurement is 12, that reference will compensate, and we always are looking from the same place, let's say. So when we make, let's imagine the case that you are saying. So you just have one microphone, so you can make 8 measurements with the same microphone. So you just put reference number 2 and measurement number 1. So you put reference number 2 in all of them, you put microphone number 1 in all of them. So it's the way of using just the same input and the same reference. So let's imagine that you put microphone on position number 1. So you use number 1 engine, okay? You generate the noise. Okay, let me just close and open my AU lab because it's not working very well. So let's use sweep. Okay, position number 1, sweep. Okay, now you can take your microphone. I'm on a very little place, but I will put my microphone like half a meter away from my speaker. Okay, I just turn on the engine 1 and turn off engine 2 and generate. Okay, and so on and so on and so on. So you talk about like sync or find delay between reference and measurement. So if you look to DSP number 1 and DSP number 2, they tell you what is that time, okay? Because Rita uses impulse response to calculate that. So if you go to live IR, that is live impulse response, you can see the 2 impulses here, okay? Let me just make a zoom. Okay, so impulse number 1, impulse number 2. So we know the time. We know exactly the time. So when the measurement goes to DSP, you know the time. So how we can synchronize the 2 measurements, okay? Normally, we sync for the one that have more latency, more time, okay? And you see that Rita tells you what is the difference automatically. So 142, more or less. So you can pick delay and put 142. So they are in time. You can see in live IR that they are now in time. And now you can sum it, you can average it, you can make whatever you want, okay? So the idea is don't make noise, please. take 2 sweeps, okay, and take decisions. This is the idea of Rita. So you are always seeing here the time of your microphones. So if you put a microphone away from the speaker, you will get more time. And if you go closer, you will get less time. So first question about sync, about find. You are always seeing here what is the impulse time, okay? You are seeing always where your impulse is. You can see here, up, okay? It's the way that it works. For example, if I make, let's use these 2 measurements, okay? But let's imagine that we make 8 measurements, okay? We make all the measurements without syncing, okay? So number 1, whoop, position number 2, whoop, position number 3, whoop, and go until 8. So if you are measurement the same speakers or the same system, let's say, okay, you can just pick this option that says sync all, okay, at right, okay, and what sync all do is just see what is the impulse with more time, okay, and apply the difference in the other ones. So that thing that I made manually, so I pick find on the impulse with more time, right? And then I apply manually the difference, 142, okay? If you choose sync all, Rita does it for me, okay? You can see that everything is 0 because they synchronize with the number 2 and put the delay as I have done manually, okay? So you can use this function sync all if you are dealing with the same type of speakers, let's say with the same range. So if you are measuring the arrays, okay. If you are measuring the subs, okay. You can't do it if you are dealing with PA versus subs, for example, okay? Because the time is not, you are trying to find the correct time in the crossover area. So it's the down part of the PA and the upper part of the subs, okay? And the delays that appear here are always looking for the upper part of the signals. So if I have a PA on the 1 and a sub on the 2, okay, the times that appears here are appears looking for the upper part of the PA and the upper part of the subs. Okay, so it's not the place that I want to deal with. Okay, so if you are just, for example, dealing with the impulse or measurements from the PA, okay, you can use sync all. Or just with subs, okay, you can use sync all because Rita always uses ETC, okay? Always uses ETC method to discover the time of the impulse, okay?
No, one small question, if
Yes,
you
Oscar,
don't mind.
please.
What you're saying right now is that Rita is looking for like the peak value of
Yes,
every impulse. So if you have the peak value for a full range speaker, of course,
yes.
different. Is that is different from the peak value for a subwoofer, right?
Yeah,
So
what I'm saying, let me try to clarify. Let me take
okay.
2 measurements, okay? Let me just put an I pass, okay, in engine 1. So it goes to DSP number 1. Let me just put my microphone a little bit closer. Okay. So number 1. Okay, and now I will put low pass filter, okay, and take the measurement on engine number 2. Okay, what I'm saying is that I don't change the position of my microphone, right? But the time is different. And if I use the sync all function, okay, I don't have my crossover region right. I don't know if I explain.
Yeah, in that case, you are trying to synchronize, let's say, 8 kilohertz with 100 hertz or something like that.
Yes, is that
and that is not what we want to.
Yes, but it's a common mistake. So many people that uses Rita always look to the time, okay, that we can find here. But this is just, we can just use it if we are looking for a speaker with the same frequency range, okay? Because they are always looking for the higher portion, okay? Just to know that if I'm using two speakers, the speakers with the same frequency, we can use it. If we look, for example, for PA and subs, we can't use it, okay? We can't use it directly, okay?
Great.
So, so I think that that right part of the engines are what it is, okay? You can put some name on it, okay? Test, okay? So let's came, I will make a measurement with sweep. So one important thing, the time of your excitement signal will determine how distant you can be from your source. Let's say if you are if you are close to a speaker, you can use a sweep of 1 second, for example. But if you want to read 100 meters away, you have to take a sweep with more duration, more long sweep, okay?
How long do you use? What do you use, Pepe? What do you use?
So let's say until 50 meters, more or less, you can use a sweep of 2, okay? If you want to use, to see what happens at 75 or 100 meters, you can use 5, okay? For close measurements, you can take just 1, okay? So normally, I always use 2 and 2 or 5. Normally, it's what I use. The sweep has some advantages, so that are in comparing with pink noise. So we have more floor noise on the results of the impulse. And for example, if we have external noise on the ambient, it will not affect our measurement. So everyone always already obviously measure in a place with people, with cars, with lots of noise, and normally we see when we excite our system with pink noise that external noise will affect our measurement. So sometimes we have to talk with people and say, please don't make noise. I need 5 minutes to make my measurements. Okay, this is not a problem with sweep. So the external noise will not affect your measurement. Okay, and it's a great advantage. So
I have a question for you.
yes, please.
Let's erase. Let's erase and let's pretend. Let's pretend I need to get left, just the left of the PA. Let's say I'm in front of house. I'm trying to use it. Like, let's say this is what I'm going to use. I need to get left, left closed, left mid, left far. I need that on the right, and that takes 6 engines.
Yes.
If I play a little bit with the sub, I'm out. I'm out of memories. That's one problem.
Yes. Yes.
I need to know where they are.
Yeah.
I'm pretty sure they're in a file, in un folder. Where is the folder?
Yes.
I need to access to that.
Okay.
So we say the time on the right is the time the signal goes to the system, sounds, come back to me. That's
Yes.
the time. The time on the left is the time I'm going to move the graphs so I can see them. I only have one problem. I set up my time with the speakers and I get like, I am here and I'm going to set the subs here. Here's what I'm going to make the summation. If you're, so I put it there. I put on time mid 100 and then I can move my subs with my hand touching the delay time on my mixer, you know, so I can move the face in my screen
Yes.
with touching something else. I'm not understanding how to set up the system so I can work with it. Gracias.
So let's try to give an example. You talk about different things. So first of all, I have made some measurements on engines. They goes direct to the corresponding DSP and they are not stored in any place. Okay, now they are not stored in any place. So I can make measurements and just see, okay, these and these I can apply, for example, I'm not using. So I can make my adjustments with my virtual DSP. So I can make gain, okay, virtually, and I can saw what happens on screen, on my impulse, okay, on my measurement. I can rotate, invert polarity. I can put delay, okay, and I see what happens if I put delay. So I can pick some sort of filters, like linkage Riley of second order, and filter the signal and see what happens. So this is the same that I can do with, for example, a continuous excitation signal and processor and everything. So I don't need a continuous signal and I don't need a processor because I have it here. And because all of that functions are invariant on time, so are always produce the same result, the same output, okay? And they are predictable. So we know that if we apply a linkage Riley of second order at 1K with, yeah, that will produce a precise phase shift and a precise filter of my signal. So the idea is, okay, take your data, take your measurements, and then think, try, and at the end, you put that values on your real processor, and your adjustment probably is okay. You can confirm, okay, you can make another measurements to confirm that everything is okay, but every filters that you can see here are predictable and are always produce the same results at the end. Okay, so first of all, we have a processor per each DSP. Okay, so each DSP have gain, polarity, delay, high pass filter, low pass filter, and filter that is parametric, low shelving, and some crazy ideas of Magoo. We have fine delay and we have clear delay for each DSP, okay? So this plus 7 more, okay? So 8. We have 4 filters per each processor, okay? So if you want to make more parametric EQ, for example, or apply all pass, you can go to parametric EQ1 that corresponds to DSP number 1, or parametric DSP number 1, 2, 3, 4, okay? And DSP number 2 that corresponds to 5, 6, 7, 8, okay? So it's 4 more filters, okay? 4 more filters that is exactly the same that you can find here. Okay, so the same options except the synchronizer are on these filters, okay? Are exactly the same options, okay? This is the DSP.
What's in the synchronizer way?
We can see, so
It's a very good concept that
Eh.
comes from Magoo, as
Yeah.
everybody knows.
so I can show you, and with this I can explain another thing of Rita that for me it's a game changer and changes my life. Okay, I can say that.
Espérame, before you keep going. So what I was asking for in my smart sequence, my scene sequence, when I do stuff in real, I'm gonna not do that anymore, right? I'm
No.
gonna do it this way.
Tom, yes.
Okay.
Or just go take your measurements and go to bedroom.
Yeah, and just be
Okay,
quiet.
to the hotel
And-
and make,
Okay.
and then come and do it. So
Can I still do it the other way, or there's no way of doing it?
okay, the idea of Rita is to have a tab for virtual measurements or offline measurements and a tab with real measurements. Okay. Now we are working on Rita 2.4, that is, let's say, virtual time, okay? And we are working in another, let's say, the full concept that is Rita 3.0, that is real time, okay? And the idea is blend it on the future, okay? So,
okay, so for now, I just keep it this way.
This way,
Okay.
okay?
It's fine. I can do it.
In the I think the one of the next steps that we will find on Rita 2.4 is the possibility of have air RTA and spectrograph in real time. Okay, so not dual channel FFT in real time, but RTA and spectrograph in real time. Okay, just one channel FFT, okay, and spectrograph, because during the show it can be useful. So, but is that the idea? What I'm saying is that let's imagine that I don't have microphones, I don't have speakers, I don't have nothing, okay, and I want to learn what makes how works filter. I can just clear everything and I can just go to an engine, in this case to an DSP, okay, and turn it on. So this is a transfer function of my processor. So this is perfect, okay? Flat phase, flat frequency. So I can choose whatever filter I want and apply it. So let's say I want to choose Butterworth at 500 and order 4. Okay, it's that's the behavior of the filter. So I can study, I can understand how it works, I can show what is a better word, what is his behavior.
Go to Chingonizer.
Okay, is what I want to do. So let's imagine that no is flat again, and I go to Chingonizer MK1. So Chingonizer is it's a concept that Magus talks a lot in his seminars, that is working with shelvings. Okay, so if you are closer from a speaker, probably you want less high end, and if you are uh, away from a speaker, probably you can put a little bit more and try to uh, choose a better trace, let's say. And so the Chingonizer, the idea is choose a frequency, let's say 1000, 1K, and put 6 dBs. So it will apply a shelving filter of 6 dBs on the high end, on the high portion of the signal, and apply a low shelving of minus 6 dBs on the low portion. So just that. It's just a tilt filter, okay? Sort of tilt filter, okay? You are put more highs and take lows, okay? It's just what it is. So you can deal with the slope node here. It's fixed. Okay. So it's the opposite. I take off minus 6 here and I put plus 6 here. Okay, this is Synchronizer. The version MK2 is a little bit different, so you choose. It's like it is putting 2 shelvings at the sides and a little bit of parametric on the middle. So if you
From there,
put
you just go to the folder, save to folder, save, and then you just send it to me and I do the job, right? O sea,
Yeah.
to save that graphs, how can you save them?
Yes.
Just with a folder in
So
refresh?
if you, for example, okay, you want to see how it works, I show you, and then I can make 2 things. Or I save as a snapshot that it normally works on most analyzers that I know. So you save a snapshot of your measurement, and it's what it is. It's a photo. You can make anything with that. So if I want to save that line, I just go to my DSP where measurement is, or this line is. I click right button and choose save. Okay, save. So it's here, my line. So I can take it off my engine, my DSP, and I can turn on or off my snapshot. Okay, I can Shingon MK2. Okay, I can change the color or delete the measurement. So I can pick a different color. Okay, or I can delete. Okay, if I have lots of snapshots, I can mute all, that is disassign, okay, or I can clear all. Be careful with this button, because right now there is not a pop-up warning you. So if you clear all, it will clear all. So be careful. Okay, so it's a snapshot. So every buttons that say save is you have to remember that is saving a snapshot. Okay, but the good thing of Rita, is that we are dealing with impulses, okay? So the impulse response have all of the information of the measurement. So that the measurement have frequency, have time, but we can take, for example, acoustic parameters from the impulse response. We can deal with that, with the impulse, change the impulse, okay? So what is important to understand, I will create a folder here on the left, folder that I call Zoom, okay? I select, okay? I select the folder, and I will turn off my snapshot, okay? This is my engine, okay? I right click on it and make save, and they save a snapshot. But if I choose to export, okay, that will save my impulse response, okay? So in that folder now, I have a wave file that is the impulse response of that signal. So is the impulse response with this filter applied, okay? So I can see on live impulse response here, okay, that if I take off the synchronizer, for example, the impulse is perfect. It's like a Dirac impulse, okay? But if I start to put some sort of filters, okay, I change my impulse, okay? So this is what happens to the impulse response when I apply filters, okay? And with the export option, I save the impulse, okay? With all of the things that I apply on the DSP, okay?
No, no, not okay. So when you do the impulse and then you touch it, you, let's say you edit, you edit.
Yes?
When you do save it, you keep the edit or you
Yes.
keep the original?
No, I keep the edit one,
The edit.
okay?
And let's say I like this edit. Save, edit one, new filter, save, edit
Edit
two.
two, yes,
So I have to have all the memories and then compare one. Okay. Okay.
yes.
No, no, just to follow, just to understand
yes,
how to
yes,
use it.
yes.
TF transfer function 127. Next one is going to be 128. Es consecutivo.
Yes,
El memory
yes,
name.
yes,
Okay.
yes. Because now you have an all pass, a low pass, and 5 filters, okay? So in one measurement or in one DSP, you can apply 5 filters and one high pass, one low pass, gain, polarity, delay, okay? In one DSP, and you export with all of that data, okay? But you export the impulse. The unique parameter that is not exported is the find delay, okay? The time, because you can use this in one situation and tomorrow in another situation, okay? So for example, I can pick the measurement of one speaker, one brand of speakers and one model, and in the another one is another brand of speakers and another model, okay? And I want to make it compatible, for example, using all pass filters. I can make that work offline with the impulse, okay? If I take 1 meter away the first speaker and 2 meters away the second speaker, no problem.
Oh,
I can put it on
then I have a
time.
new question. So
Yes.
when you export, you do take the original and you do take all the settings. You don't take the final result. you take everything. So that's the way you can change it. You have everything. When you say you're taking everything in the
Yes.
export, you're taking the time, the settings, all the different changes you did. So that's the only way you can change it. You're taking everything, the engines, todo.
Todo except the find
time.
the time, the sync time. Okay.
Yeah, but the system time, not the internal, the time against this. I see what you're saying. Okay.
If you put delay here, okay, 40, okay, it saves with 40,
Yeah.
but
Yeah.
not the syncing time. Okay,
Sí, sí,
not
sí.
the syncing time. This is important. So
Chingón, chingón.
export goes here. Okay, this is automatically with a name. You can double click and test one. Okay, and you can go, for example, to engine number 2, right click and make import. Okay, import will pick the selected impulse response from your memories, okay, and take it back, in this case, to engine number 2, okay. Okay, it's not the same because I already changed it the number 1. Okay, let's say I will save this export. Okay, test 2, and I will import test 2, okay, to engine number 2, import. You can see that is exactly the same.
And the time on your right, punto 02, is the time of your system. That's a real.
Yes, it's a difference. It's a difference of one sample. Sometimes we have a difference of one sample. Okay,
Nada.
But nada. So right click on DSPs. We have import, export, save. We already see it. Save for snapshots. Import to take memories to our engines and tweak the signal, and export to save from the engine to the memories. Okay, and last option is load. Load can load external impulses. Okay, so for example, I have, let me see where I have it. So applications. Let's say that I have here some memories, okay? Some wave files that are impulses, okay? So I can pick these impulses that are wave files and send to you. And you can import to Reader and read it, okay? So I can make measurements, send to you, just picking that and send it in an email, okay? For example. So impulses are saved in wave files, okay? So in that case, I am loading, let's say, what you send me. So you send me that impulses, and I want to see it on Rita. So I pick the option load, okay? And now it's possible to multi-select, okay, files. So I put open, I choose open, okay, and look to the DSPs, okay. It starts on 1 and goes putting every single impulses that I selected, okay, for the order that I selected.
Where are they? Are they in a buffer? They're in the buffer, or are they in your machine? They're in the buffer, right?
I load it from a folder that I have, okay.
Mm-hmm.
Now they are on DSPs, but they are not on memories.
They're not on the hard drive, on the buffers. Yeah, on the buffer memory. They're just
if you have to save it, you can just
save.
for example, out impulses and go and export, go export, or we have an option that says export all.
Chingón.
Oh, export all. Okay, let's see. Okay, they are here already. Okay, so now it's the name is a random number. Okay, so you can change it now. Okay, but is exactly the same that you have in, let's say, in the buffer, in the DSPs. Okay, so we can, instead of export all, we can save all. So we make a snapshot of every engines, save all, and we can see that they are here. Okay, save everything. Okay, everything that is on. Okay, so if it's off, it's not saved. So we just save 1, 2, 3, 4, 5, 6. Okay. Clear DSP, it's what it is. So it clears the filters on your DSP. So for example, I have liquids, parametric, elliptic, I clear, and that goes to none.
Oh, you took the names. You took the names too.
Took everything. So I took everything off. So it's like, okay, let's, I already exported, I already save it. So I want to clear and use these DSPs for new measurements. Okay, so I can clear all. Okay, just clear because I already saved it. Okay, or exported. The idea is that with snapshots we can make anything we can't process, but with the impulses we can make everything. Okay, so we can process, we can tweak. So clear delays is what it is. Sync all already explained.
Clear delays between this for the system or the other ones.
Let's try one thing. Let's make it here. Okay. Okay, now it goes. So let me just let me just put another measurement on 2. Okay, let's imagine that is same sort of speakers. So I sync all. When I'm synced, I cannot clear delays, but if I have 4, 6, 8, I can clear delays. So clear delays is clear that delays, not the syncing delays, but these delays. Okay, the processor delay, let's say. Okay.
Yeah. How do you guys call the left part? The processor, right?
Yes, processor, DSP.
Processor. Claro.
Okay. We have day mode or show, clear DSP, clear delay, sync all, export, save. Okay, and we have 2 more options here that are sum and average. Okay, so let's start with sum. I will clear everything. I will put, let's say, let's simulate that I have top.
Nuno, may you mute
Yes.
all the snaps?
Yes, please. So, mute all. Mute all. Okay, it works. Clear all. It will delete everything. So let's go to magnitude and phase. Okay, magnitude up, phase down. So what I'm trying to do is just apply an high pass filter at 500, let's say. Okay. Just a second, please. Okay. So I will take a measurement of my so let me make difference. So 100 Butterworth second order. Let's say if it works. My OLAV is not good, so let's try again. So it's my subs. Let's imagine that it's my subs, okay? And let's imagine that is my PA. Sorry. Pass high pass filter. Okay, what is happening? Ah, sorry. Okay, let's imagine that I have a sub and a top. Okay, that's my PA, my subs. So let's just, I just take two sweeps, okay? Two sweeps, one for the subs and one for the tops, the PA. And I want to see what is happening. So I found the system. I take two sweeps on a position, for example, and I can see what is the sum of the two measurements. So I can see what is the sum of the subs with the top, with the PA. So sum will show me my summation, okay? One more time, I'm dealing with impulses, so I can sum it, okay? If I pick the right click here, I can just see the sum line, sum trace, okay? So I'm just seeing the summation, okay? Or I can see everything. But I can save as a snapshot this summation. So save. It will put here a new snapshot with the sum. Or I can export the sum as an impulse. So I can export, and now here I have my sum, okay, that I can, for example, import to a processor. Import. Let me just turn off everything else. Okay. Let me just, so the sum is the same, but this one is an impulse that now I can tweak. Okay. So the idea is take your measurements, take your data, and tweak it, transform, try it. Okay. So let's go one more time for our PA and our sub, okay? So we can make a sum, but let's say, okay, I want to synchronize with my PA, okay? This is the find delay, okay? So what is the idea? I can see that is reversed, probably, because I have parallel lines. So if I reverse one of the signals, okay, I tweak the signal and I can see what now is the summation. Okay, now I have sum. Okay.
You're entirely hired for the job. I just have one question. If I wanted to see the impulse to know which one to flip, how can I turn this into impulse mode and just see the impulse?
Yeah, you can go to live.
Impulse
Okay.
response, claro.
Impulse response,
Okay.
and you can
I
see
either,
just see this is the impulse response. Let me put it. Okay, this is my impulse response flipped, and this is my impulse response not flipped. In this case, this is negative polarity,
claro.
and this is positive polarity.
Okay, so in this case, we can say everything's on 3. Everything's flipped. The
Yes.
PA was flipped
Yeah.
in the beginning. Okay, that's what I just wanted to
It's
know how to know.
it's this
you know?
it's the same between the PA and the sub. It's the same if I reverse the polarity on one or on another.
I just wanted to see
Yeah,
how
see,
you
yeah.
can see the impulse and make sure where you're standing.
Yeah.
Perfect.
So you can see it here on live IR. So live IR shows you every single changes that you make on DSP. Okay, every single changes that you make, you will see on live IR. Okay, so let's imagine that, for example, that is a common thing. Let's say that it's not a good example, but let's try it. Okay, in this case, I put just some delay just to simulate a real world. Okay, so I can see that my subs, that is the engine one, that is this sub PA. Okay, my subs are
later.
uh, are not delayed, so are arriving first. Okay, so they are arriving first, so I can now, for example, apply a delay of 3 milliseconds, not 3, but let's try 3 milliseconds. Okay, 6. Okay, I passed. So 5. So 3 is 1.3 reversed. No.
4.5.
4.5 in reverse, yeah.
Yeah. Yes. So I can make everything. I can make everything and try it. Okay. So what I want to show you is that, let's imagine that I'm in the opposite situation. So my subs are more delayed than my PA. So in a constant noise solution or environment, I have to redo my measurements okay? Because I can't synchronize with the other measurements. So here in Rita, we can. So we just take off the find, that is synchronization from the PA, and we can just synchronize with subs. Okay, and now I have my PA arriving first, so I can put my delay here. I don't have to remeasure. Let's say that the find option is just make me choose what point of view I want. Okay, I'm looking from the point of view of my subs, or I'm looking of the point of view of my PA. Okay, so I don't have to remeasure anything. Okay, I think it's very, very important and good thing.
I got a question for you. The way
Yes.
you play with it, it's because you work with it, so you can go and play. What you're doing is because you're very good at it. You can go bring this time to that time, or the perspective game. But I have one question for you. If I want to set up the same time PA sub, my decision of where I put the microphone, if I put in
Yes.
the wrong place, it will be wrong, right? So
Always.
me being an engineer and saying I want it here, it's still applying to the concept.
Yes, of course.
Okay.
Of
Okay.
course. So
Then I can go home. If I took the correct measurement, then I can go home. Okay.
we talk a lot of that that concepts on our courses, but simplifying, the place where you put your microphone is the place where you want to point your maximum summation.
Claro.
So
O sea, claro.
if you have for example, let's imagine that we have a PA and subs flown, okay? Just to be a little bit more easy. Okay, you make everything at 20 meters. So your maximum summation is at 20 meters. So it's pointing there. Okay, if you put your microphone back, okay, you are like taking your low up and pointing the maximum summation there, or the inverse if you go to the front. So it's your decision, okay?
Okay.
It's your decision. It's always your decision. So what we can make, just to end this first part, as we use the sum function, we can use the average function, okay? And this is super cool because we can make some measurements, so in different positions, and instead of working looking into one microphone position, we can make decisions looking for our average trace. Okay, let's make an example to understand. And let's say that I just have one microphone. Okay, so I have here a sound card with two inputs. One is for reference now and one is for microphone. I have a microphone that is for studio recording voice, so it's not it's what it is.
It's what it is.
It's incredible. So let's say that let's say that I'm trying to understand what my array system outputs me from close to distant. Okay, so I have a speaker here. So close is first measurement. So I turn it on. 1, reference 2, sweep 1 second, it's okay. So generate. So let me just take off my filters because I have it here. So okay, position 1. Let's move my microphone back a little bit. So engine number 2. Position 2. Engine number 3. Position 3. Okay. For example, okay. I said that you can see on live IR, for example, you can see the 3 impulses, okay, where they are on time, okay. But if I want to make an average impulse, okay, if I want to pick each of the impulses and make an average impulse that will give me the average frequency and average phase, let's say, okay, I have to pick the 3 impulses and put it first on the same place, okay. So I'm measuring this my speaker, so it's the same speaker, all measurements, so I can use sync all function, okay. They will the Rita will sync with the one that have more sync delay and apply the difference on the other 2. So if I sync all, that third goes to 0, the other ones goes to 0 too, because we have applied delays, okay. And now I have the 3 impulses on the same place, okay, they are on the same place, and now I can average it. So let's forget the, okay, I can average, let's put just solo. So this is the average impulse of that 3 impulses, okay. It's a new impulse, okay. Let's go to magnitude. So this is my frequency and phase response for my average impulse, okay. I can see the individual ones too, okay. But if I look just for, let's say, this impulse, I get a response. If I look to this one, I get another one. If I look to this one, I have another one, and I start to have some bad coherence and changes on phase, okay, and some cuts on frequency here. So instead of working and take decisions based on one position microphone, I can make some measurements and work on the average impulse. So in this case, I'm looking from closer to back. So if I have an array, probably I can see that probably I want to put a little bit more of high end on the higher speakers, and take a little bit on the low part of the array, but it's what it is. So what I'm just trying to show you is that we can make an average, okay? And the average can be made, for example, if putting the microphones like one here, one here, one here, one here, for example. It's not one place. It's not one position. It's 4 positions close to each other that can make a better result, and that average will take out from our traces what is uncommon in every measurement. So every positions have its own characteristics, okay, because it's characteristic of the position, okay. If I have that position characteristic on 1 and another characteristic on 2 and another on 3, that characteristics, that can be a reflection, that can be noise, that can be something, will tend to disappear from the average impulse, okay? So we can make average impulses, okay?
How many signals can we average? 8.
8.
Of course,
Yes.
I knew it.
8.
I get really nervous when I see 48 traces per octave. How can I go back to kindergarten and just bring down a notch the graph?
Okay.
Let's
Let's just finish one thing. I'll show you that in a minute. So let's imagine that this is my PA, okay? I already synced, right? And I calculate my, sorry. Cinco. Okay. So let's imagine that I save my PA trace as an impulse. So I can now take it back to a DSP and change it. Okay, I can make things, I can tweak it. But for example, let's imagine that I want to, in that microphone positions, now calculate an average of subs, for example. Okay, I can make it. So I don't move microphones. Okay, so I don't have to make any changes to delays. Okay, so I can now, for example, let me try to put I already save here, okay? Save my average trace. I will just desynchronize. Don't touch anything because my microphones are in the same positions, okay? And now I just generate. I can't do it right now because I don't know what is the exact positions, but let's say that is the third one is that one. So
No, a question. You can do this if you have only one microphone. You can do this exercise.
You can make PA on position 1 PA sub.
Okay, PA sub. Move the microphone.
PA sub. Move the microphone PA sub. Yeah.
All the input response, and after you can do the average.
See, yes. So
okay.
I can try do it that way. So, for example.
Me perdí. Con lo que dijo Pepe.
Vamos a hacer así. This is my PA. Okay. Why it's not working?
You have time. 4:40 abajo.
I think it's my OLAB is not helping me. So now it works. Okay, let me just make one more time. So my PA my sub. Okay, then I will change my position now. Okay, I'll change my position. So number 3, my PA. Number 4, my sub. Okay, so I will just make like export. Sorry, where is export PA in 1, sub in 1, PA in 2, export sub in 2. Okay, so I just take 4 sweeps, okay, 4 sweeps, and I save it. Let's clear everything. So I just use 2 positions, just to simplify. You can use more. Let's say that I want to import PA here, PA1, and I want to import PA2 to engine 2 import. Okay, so what I have to do is PA against PA, so I can sync all. So I can average it and export it, right? So this is my PA average. I take off the average, I take off the find. Okay, I will put in the same engines, for example. Okay, I will put my sub, and I will put my sub 2 on engine 2. Okay, so I can just apply the average and export. Okay, they will go with the same delays here. Okay, so my microphones are in the same position. So I export sub average, right? Let's clear everything. So now, instead of working with one microphone in one position, sub against PA, I can import my average and I can import my sub average. Okay, and now I can take my decisions. So let's put it here. Okay, now I'm seeing PA versus sub. So I can't look to this time. Okay, so what happens is that sub is more delayed. Okay, so I can just take the find off. I choose the second one, another point of view. Okay, and I can, let me see, take my decision. Okay, and see what is the sum, for example. So sorry. So in this case, I can put 2 here, 0 here. And I synchronize with the, no, sorry. I'm doing something wrong. So
do the optimization, and after the optimization, the synchronize and synchronize with the PA, the main system, and you can see all the frequencies. Now synchronize what subwoofer.
yeah, okay, here.
Put the delay.
Fine, okay, like
and
this.
Now synchronize with main system.
Yeah.
And you can see all the frequencies on time. And you can see the zoom.
Yeah, sure, thanks. So we can see the sum. Okay, so it's a way of using averages with just one microphone. So position 1, PA sub, position 2, PA sub, position 3, PA sub, etc, etc, etc. Okay, then we save everything, not save, we export everything as an impulse. Okay, then we bring to our DSPs our measurements from all measurements from PA, for example. We can synchronize with all of the impulses and calculate the average. So we switch the PA impulses for sub impulses on the same positions, okay? And we can calculate the average of subs on the same positions, okay? So we get an PA average and a sub average, and we can make our adjustment with dealing with the averages and not with a single microphone position, okay? We can make it with more than one microphone, just instead of using just the same input for measurement, use 1, 2, 3, 4 for 4 microphones, for example. And with one sweep, I take 3 microphone positions, okay?
No.
Yes?
We have a question.
Yes?
From Enoch. Please, do we do this with the mic on the floor or on stand?
Let me try to find I don't know where is my, oh, it's here. Yeah, normally, okay, no, normally I do this with the microphone on the place where people will be. So if I'm on a theater and I have people seated, I tend to put my microphones more or less on the places where people will be. When I adjust PA versus sub, sometimes I tend to put it on the ground just to see the delay and try to escape from the bounce floor. But with averages, helps a lot if you use or you make your measurements on stand, okay, on mic stand. But sometimes I put my microphones on the ground when I want to see delays between PA and sub, if my phase ruptures occurs on my crossover region, Okay, to avoid that, I put my microphone on the floor. But normally, I use it on stand. Okay, so you are talking about scale, I think.
Oh yeah. The graphics.
The graphics. Okay,
let's try to
so
make it for kids.
first, we have some shortcuts in this version. So we have, let me just clear everything.
Gracias.
We have some shortcuts to generate, to sync all, export all. So we have it here, just to know. We have here to choose our audio device, and this player function is not working very well. But the idea is you can choose a file or generate a sign or a sweep from here. Okay, but we are having some strange behavior, so you can try it and see if it works for you, but is what it is. And in audio device, we have the possibility to choose our outputs and our inputs. Okay, so very important, Rita now works at 44, 48, or 96. So what is important for you to keep in mind, if I choose to work on 44, for example, Rita will warning me that the sampling rate must be the same of my device. So if I choose 44, yes, I have to go to my audio device and change it to 44. Very, very important. Okay, so in this case, I will keep 48. Yes. So when you choose an output, it will show you the maximum output value and the maximum input values, just for information. And now if I plug in this moment a new audio device, okay, I can pick the option refresh and the new audio device will appear here. Okay, if this is the other devices that appears or that Rita knows or detect when Rita turns on. So if with Rita on, you take you turn on a new device, you have to refresh to appear here and apply. In this case, I'm using Black Hole to apply some processing, and I'm using my Presonus as an input. Okay, apply. So shortcut is okay, device is
I
okay.
was really talking about the understand preferences.
Okay.
La resolución.
Sí. Let me just let's say, okay, import that. Let me turn on this. So we have the sorry, what happened here? Okay, my computer is dying, sorry. Okay. Import. It's not working here. Sorry. Okay. So
Ya lo vi. Ya, ahí está. Gracias.
here we can smooth the trace. Okay. It can be not good, but is what it is. Okay. But here we have on preferences some great stuff. So we can change the color of the engines. Okay. These units, metric or imperial, are not working, but we can choose, for example, the thickness of the line. Spectrum is not yet implemented because we don't have it yet, neither impulse. But on transfer, we can choose if our grid, just the grid, is on octave, third octave, or decimal. Okay, just the grid. Oh, no, normally we want to see that this way. And the epsilon axis, we can choose what is our steps. So if I put 6, that goes from 0 to 6. If I put 18, the same. Okay. So it's the epsilon axis resolution. Okay. We can see just the low frequencies. Okay. Just around 200. Okay. Just the mid frequencies, or just the high frequencies. Okay, or all. So fine delay is using this for default. I never touched this, so it's okay for me. But here on phase, we can see our phase from 0 to 180 and 0 to minus 180. This is the normal way of seeing it on analyzers. But let's imagine that we have a crossover point that occurs near 180. So we are looking sometime for here and sometime for here. So we can see the phase from 0 to 360. So now it goes from 0 to minus 360. Okay, just to see it better if we need it. And we can see the phase as group delay. Okay, but let me put this on. Sorry, I have one thing there. Group delay. Sorry, something is not good. Okay. I have here a measurement.
No, a moment. I think you have a zoom or an average. Double click and zoom or double click and average in the
here.
right
Yes.
button.
Yes, it's zoom. It's zoom. Yeah.
An hour book.
Yes, it's zoom. I assume that is
what
average,
was
but
that? Pepe
it's
turned off the graphic.
no. It's a sum. A sum is still on memory, on buffer. So it's showing.
So the buttons, when they're gray, means on. When they're black, means off.
Yes.
Okay.
But they are off, but it's on. Okay. So sometimes it can occur.
Okay.
So let's bring it here one more time. So we can see group delay. We can see phase delay. Okay. That is the delay per frequency. And we can see unwrapped phase too. Okay.
Nuno, synchronize is better to obtain.
Yes. Thanks, Pepe. It's here. Okay. Let me go here, preferences. Transfer. So phase delay. Okay. Now group delay. Now unwrapped phase. Okay. This is the phase without the wraparounds. Okay. This is unwrapped phase. So we can choose to, what is, if you want to see in steps of 30, 45, 90, okay, or phase wheel, that is how Magu likes to see. So 0, 90, 3 dVs of summation, and the principal points, okay? So you can see the phase like that. So this is the visual options that we have, okay, on read on preferences, okay, or Command P or Control P. So one thing that we can do now is export everything that we make on our DSP, okay? We can export to an Excel file. So let me just put some sort of filters just to here. So 10, 8, it's completely random, okay? -6. So let's say I want to export the information. I can export to my desktop info reader. Save. So now I have here an Excel file with all of the information from my DSPs, okay? So I can take decisions and send you an Excel. So use that, try that, okay? It's a cool feature on this last release.
Sorry, Nuno, a moment. A comment. Now only export the DSP. The next version will be the option to import the Excel DSP.
So the opposite procedure. So we have an Excel and we can import to Rita.
In that case, we can use clear all, get rid of everything, and it's gonna work, right? The clear. That's why you have the clear all to erase everything.
Yes, the clear all is raising everything. So we can export before everything and save it and then import it, and you'll get the same state. Okay.
I got really nervous when you erase the first time and you erase all the names because I freaked out because in the old, in the other way of measuring, you need to measure the same thing 25 times
No,
because that's the way.
please no.
In this case, you make 5 pictures and you just never touch it again.
Yeah, because they are not pictures. The idea is that, okay, they are impulses. Okay, so let me just show you. We already see the phase, the magnitude, the live impulse response. Okay, live impulse response. The wave is not working right now, and we have 2 tabs of acoustic IR. Okay, so let me clear everything. So what is that? No.
No, acoustic R don't erase the measurement. You need to do a new measurement.
A new one. Okay. So what is the acoustic here? The tab in the upper part and the tab on the down part is exactly the same, okay, with the same options, but you can see 2 impulses responses at the same time. So if you want to compare, you can do it, okay? So let's imagine that I want to see an ETC impulse, okay? I don't want to go very deep because this part is in development yet, but just to show you what is the main idea. Here you will have an option that is now not working very well to import direct from one of the 8 engines to here. So let's say I choose 1, I choose 2, and if I make 2 measurements with 1 and 2, the impulse response will appear here in ATC mode, okay? So that options 1 and 2 will bring the engine direct to here, okay? 1 to the upper graph and 2 to the down graph. So this is not working very well when you choose to import direct from the engines. So what I can say is that you make the measurements that goes to the DSPs, then you can export that measurements and have it here, okay? So you can now pick and choose import, okay? Import will import from your memories, okay? So if you choose PA1 and import, it will put PA1 impulse here, okay? If you choose PA2 and choose import, okay, it will appear here, okay? And you can compare. You can load external impulse responses too. So if I pick external, it will open. And let's say that I go here, audio, memories, pink or sweep, for example. So this is how a sweep looks like. And I will put here external. Sorry. Pink. So pink down, sweep up. As you can see, you have lots of more noise with the pink and or with the sweep. It's the same size of measurement, okay? Using a sweep or using a pink noise. And the noise floor is much higher with the pink when you compare with a sweep. But it's just to explain you how you can import impulses to the acoustic IR. Also, so you can see, for example, the TR20 and TR30, for example, instead of see the ETC mode. Okay, so let's imagine that I will import that, PA2 import, and I can see the TR. Okay, so it's some acoustical indicators that we can see. So remember that importing.
T20 was, so I'll just look for those concept T20, T30, EDT in Google, right? It's like reverb time things.
Yes.
Okay.
You choose here what you want to see. Is clarity here, for example. Initial delay, initial time gap, delay time, delay gap, initial time delay gap. Okay, so you choose how you want to see it, the impulse. Okay, you can see, for example, in spectrograph. Okay, with an overlap of 99. Okay, so you can see how frequency goes over time. Okay, you can see linear, okay, or in log, that what we want. Okay, so it's what it is. just to remember, the options 1 to 8 is not working very well. Sometimes this not goes direct from the engine to the plot. So what I can say is to export from the DSP first to capture the memory, and then import from your memory, okay? And it will work. I think we are almost there. Last but not least, now we have the possibility of using mic correction curves, okay? So how it works, you came to mic correction, okay? I already have some curves here, okay? But let's imagine that I will delete that 2 of my MM1, delete that my MM1, yes, okay. So I'll delete them just to show how I import it. So I import, I click import, and I'll go to my desktop where I have my MM1 correction files, okay? 0 or 90 degrees. I just open it, and okay, it appears here, okay? First of all, very important, we try to accommodate lots of formats from microphone manufacturers, but sometimes they are not compatible. So we have to make some tricks. So if you have problems with that, feel free to chat me, and I will try to make the file compatible, okay? If the file doesn't appear here, or you listen like an error sound, like is the signal that Rita can't read the file, okay? Just to explain, I'm a Mac user, so if I go to Global Audio Solutions, that is almost the same directory structure on Windows, and if I go to Rita 2.4 audio and go to mic corrections, I will see that I have here MM1 mic correction, okay? So my original MM1 mic correction is that, okay? With frequencies and correction in 2 columns. And this one, it's just 1 column. So Rita have to pick the information from the original microphone and will translate it to a new format, okay? And this process can not occur very well from some sort of files. So if you have problems, let me know. Probably we'll make some video about that. But very quickly, if you found something like this here, it will work. If you found a file like that with some text, with points, and with 2 columns, it will work, okay? For example, if you use another softwares and to make your curves, let me just, for example, this format will not work. For example, this format will not work because don't have some header, let's say.
No instructions.
So, yes, so some type of files cannot work. So what I tend to explain is that you pick this and you put, for example, frequency dB, you use points, you take a space between the two columns and it will work. Okay, so this is the most common format, okay, that will work. So if we have here our correction, now we have to decide where we want to use it. So channels will give the possibility to choose what channel we want to apply. Very important. Now this correction is happening on the engine, okay? Is happening on the engine. So this channel 1, channel 2, channel 3 is in reality engine 1, engine 2, engine 3, okay? So if you are using microphone 1 on engine 1, okay, this MM1, you can put that. But if you use then the same microphone on engine number 2, okay, you will have to put the same file. So the correction is made actually on the engine, but in my sound card, my microphone is always on my input 1, okay? But this is engines, okay? Because in other softwares, this correction occurs normally on the input of the sound card, okay? So it can be tricky, but here on Rita right now, it works on the engines. The cool thing is that we can create very easily our correction files.
No, a comment, please.
Yes.
In the next version, our idea is to do this. The user can be the possibility to use correction between every engine, or the possibility they use the channel of the desk. Sorry, of the driver,
The sound card, yes.
the sub card.
Yes.
There are two possibilities between in our measurements. We can use the channel 1 in the engine 1, engine 2, engine 3, engine
Yes.
4, and for this it's better to use the correction in the input of the
sound card.
On the sound card.
Yes.
But another possibility is to do an average of different microphones, and this is better to use the engine. But it's for the net version. Sorry, Nuno.
Yes, just to inform, that is how it works now. So don't be don't think that is something is wrong, because it's the way that works now. So we can easily create our microphone reference file. Okay, let's imagine that I pick I have a super great microphone, okay, that I have my correction file, okay, apply that, everything is perfect, and I can take my measurements in Rita, okay? So, and I can save that impulse. So I save the impulse response of my super microphone, okay? And that will work as my reference, okay? It will work as my reference. And now in the same place, I will take a measurement with my low cost microphone, okay? So what Rita will do is compare the super finest and high quality microphone with correction with my low cost microphone, and we'll create my correction trace, okay? So one cool thing that I have the idea, I will make just one quick electrical measurement, okay? So let me try to clear everything. Let me see what I have here. Okay. Okay, let me take off my filters. Okay, let's imagine that I'm making a loop, output 1 to input 1, output 2 for input 2. So 2 loops, okay? So I will see what happens. Generate. Okay, not good. It's my OWL lab one more time. So let me just close it. Sorry. No. Okay. Now it's a little bit better, but I have to turn off one plugin here, sorry, because I'm making a shelving. Okay, what is that? Let me just put a little bit more gain. So that is the response of my sound card, okay? If I want to see how is my sound card, I can compare, make 2 loops, because as I said in the beginning, we are just using the loop reference to know what is the time, okay? If you are using that to with all information of frequency, obviously the difference between 1 and 2 will result in a flat phase and flat magnitude traces. So
we're measuring your interface, but we do not know if that's happening either in the input or the output, right? So
yes, yeah,
couldn't tell. Oh,
yes,
perfecto. I understand. Okay.
We don't know, but it's what it is. It's my interface is that, okay? So I have one idea looking to microphone correction possibility, okay? That is correct my sound card, okay? So for example, I can export as an impulse my sound card, okay? So this is sound card, okay? And I can take a perfect measurement that is just turn on one DSP. It's a perfect world. It's my perfect microphone, let's say. I can export and I can say, okay, this is flat. Okay. So I have an impulse that is my sound card. I have an impulse that is my frequency, my perfect world. So I can go to microphone correction and let's take everything out. Let's load my reference. In this case, is the flat impulse. Okay. So I have to go, sorry, I already have to put a shortcut there.
No, a question. I think that you do the measurement using the file, the correction file. It's okay? In the measurement one?
Yeah, okay, I have to keep it.
Okay.
I have to keep it in this case. Well, but it's not good, okay, because then I can't use it. So thanks. So what I have to do is redo my measurement without my measurements without go delete. No,
I don't understand what did Pepe say. You have to raise what to do what?
I'm using a mic correction file on my engines. So the response that we
you're
saw.
already.
Yeah,
Oh,
I'm already assigned here.
EQing on top of an EQ.
Yeah.
Oh,
Okay.
I see.
So I have to do another time. Sorry.
So you just bypass your correction and
Yeah,
then put your
just
shitty
turn
mic
it
back.
off. Yeah,
Okay.
it's better, as you can see. Okay, so I will export as sorry, sometimes I can't change the name.
No, yes, no. This is a bug. No problem.
Yes. Sometimes I can't.
No push. No push. No
Sorry,
problem. No
sorry, sorry.
problem. Return.
Okay.
For all the people, click enter and
Okay, you can
erase the
erase.
name.
It is
And push.
behind, but it works. Yeah.
This is a
Sound
bug.
card 2. Enter. Now it's the new name. Okay. So it's a known bug. If you can double click it on it, you can enter. Okay. And change. So the flat file is perfect because I'm not using an engine to make it. So they don't use the correction file. Okay, so let's go to me correction one more time. No corrections. Okay, so my mic reference in this case will be my flat file. So not here, sorry. Mic correction. No, sorry. It's in memories. Okay, so in memories we can see not that one, that one. Our impulses. Okay, so my references will be flat, open. In my microphone in this case will be my sound card. So I pick it, not that, that's memories, sound card 2. Okay, so open and sound card correction. Okay, and export. Right, so now on import tab I have one more that is sound card correction. Okay, so if I put on engine 1 the sound card correction, okay, and save it, and I make, let's keep in mind that trace, I will make on the same engine with the correction file the same measurement, and we'll see that will return flat. Okay, so my sound card is corrected.
How can we get the, should I do the same like you do, just make a flat line in my computer, or should I get a super expensive high quality mic?
No, it's what it is. I can tell you that I never use my correction files, so for me it's what it is.
That was enough.
Okay, but many people want it, and it's the possibility to have a better results on measurement, because I can show you, for example, I have here, I think.
Can you graph a correction? You can.
No, graph no, but let me see, just for example.
Well, but the graph is the correction that we saw before you made this. It was 0.5 dB.
Yeah,
from
in this
to
case, yes, for
0.1,
about,
I don't know where.
in this case, yes, because we are talking about the sorry, the sound
The
card, okay?
measurement, yeah.
Sound card. But if we look to a real microphone correction, we can see things like that. And this is just plus then 6 dBs of let's say 1200. So this is a correction file from a microphone. Okay.
So that's a correction. O sea, that's double the
Okay.
power. 6
So
dBs.
it depends. If I came here, I'm making a loop, right? Sorry, I'm making a loop. So I can just pick different correction files. So, for example, my MM1, okay? If I use it on 0 degrees, that is pointed to the speaker, okay? The correction will be that. Okay? So I can see the correction.
I see what you're doing. O sea, yeah, you're exposing one after the other
Yes.
against a flat line.
So in the case, I don't know if anyone uses a MEM1, for example, but if you read the MEM1 biodynamic manual, it says that if you are not in a low SPL environment and you are on a high SPL environment and a diffuse place, you must use it pointed to the air, to up, like 90 degrees, okay? So if you use it like 90 degrees, I don't have it here, I have to import MM1, 90 degrees. So I have two files from the brand. So 90 degrees, save, make the measurement again, and you'll see that it's correcting almost nothing. So the MM1 microphones are better, are more flat if you use it pointed up. Okay. I don't know if it's other ones. We expect the same behavior, but you can test it. You can test it. Just put on the same place and make one measurement like that and one measurement like that and see what happens. Okay. So one last important thing, you can delete folders. You can refresh folders if you put some folders on the memories folder, on the Rita folder, okay? You can create folders. And these options here, okay, they have some sort of behavior. So for the tests that we made, you have that tools here and the same tools down here, okay? But if you pick the data tip tool, that is to pick a point and it creates a data tip with the values, okay? It's a data tip, okay? You can go to the left with the arrow left, or go to the right to the arrow right, or if you want to put more data tips, you have to use now the shift key, like to add more, okay? Okay, so shift and it adds. Because if you don't use shift, it will pass this data tip, that is last one, to the next one, okay?
To erase, Alt.
To erase, right click on one, delete current data tip, or delete all data tips, okay? But the question is that the data tip tool is, you select them for the upper plot, but if you click down, it will working too. So it's not supposed, but it's not a function of Rita, okay? So it's what it is. So the data tip is linked. So if you choose data tip down, it will choose data tip up, and reverse it's the same. So data tip is linked between the two plots. But if you choose, for example, data tip here on the up, okay? And for example, end down, okay? It works the end, okay? But if you don't have any tool and you have data type selected, it will work on both plots, okay? Just to warning you. So I don't know if are more questions, but I think that we overview all of the functions, all of the possibilities, and now the important is to try. Yes.
No, this is Michael speaking.
Hi, Michael.
Hello. Hola. I have some questions about acoustic IR.
Yes.
Please, could you load one
Yes.
or two different files again in acoustic?
Okay, I can try it.
Or leave it like that. It's no problem. You can leave them.
Let me just put a key here, not here, just to have a real measurement. So import my PA measurement and import my PA2 measurement here. No, import. Sorry, spectrograph, for example, 99. So this is my first microphone measurement versus my second microphone measurement.
Okay.
I don't know if you want to see another type of...
Wait a second.
Yes.
My first question would be, where can I read or indicate which file is loaded in one of this plot?
Okay.
So I come back to my view and see two different spectrographs and don't know which file is on which plot.
Yes. It's the acoustic air part, the acoustic tabs are yet in development. So
okay.
in this time, you can't see what is the impulse that you load, let's say, or import in this case. Mm-hmm. So it will be an interesting feature to add, obviously. As I said, the direct import from the engines are not working very well too.
Okay.
So now we can see.
Okay. So
next one
is if you go to the first or upper plot and take not spectrograph and take tier 20 or tier 30.
Okay.
So regarding to choose the numbers which I am familiar with is RT60. So how can I read RT60 from your two different T20 and T30?
I don't know if Pepe can help us with that.
Yes, I understand not very well English, but I'll try it. Yes, Michael. Our idea is now this part of acoustic air is the same that Rita 2.3. That our idea is to change the manner of to work in the new acoustic air, but it's easy to obtain the tier 60, but normally the most common use is to obtain the tier 20 or tier 30 and then apply a multiplication to obtain the tier 60. But we now Nuno, ¿cómo queremos repensar la manera de hacer
we want to think a new way of doing that.
Okay.
We are working now in a different concept for to obtain a better result in acoustic air. Now I'm working with two acoustical engineers, and they say me what is the better option, what is the better mathematical calculation of the this part, because really I'm not a acoustical engineer. I need external
Okay.
help.
Yeah, yeah, I understand. Okay. And last question in general,
Yes.
I got the feeling that every time I press a button on this software, it has latency. So it's not very fast working in kind of
Okay.
I press something and it will react very fast. No, it will always react with latency.
Okay. So first of all, the software now is made in MATLAB. Okay.
Yeah.
So when you open it, it will take a little bit because you have to compile every time that the software opens. Okay.
Mhm.
So then, if you have it open, it depends from your machine, of your machine. So I have a computer here with 8 ears, and I'm making a Zoom call, and I'm making some processing inside of my computer. So my computer is. I need a new computer. If anyone wants to offer me, Santa Claus maybe can.
I have a 16 RAM computer with those two
Yes,
processors, pretty new.
this is a 16 RAM computer too, but
And it works fine.
is for the first time I start to feel that is the time to move. So I can say to you, Michael, that if the same thing is made by Pepe in his computer,
Yeah.
with the same environment, so making a Zoom call and using Reader in his
No,
computer.
I got the same issue on my computer without any
Okay.
Zoom, without any OWLAP. It's only with one audio interface, and always clicking on some function or clicking on some option, it always takes a little while for reacting. It's
What
not
I
very that fast.
yes
I know from different other softwares.
yes, it's not the most quick application, we know it, but for my experience it depends a lot uh, of our machine. So
Yeah.
if what I'm doing or not with that with the machine in that time.
So
So
my example, I got 32 gigabyte with 8 core. So
you are using a
should-
Mac or Windows?
Mac, yeah.
Mac, okay.
A comment. Yes, Michael, I know, we know this, but now all Rita versions are developed in MATLAB because it's more easy for us to work in these languages.
Yeah.
We are working at the same time in C++. This is a more fast languages, but is more difficult languages than the developed in C++ is
I can show it, maybe, Pepe.
si puedes decírselo tú, el funcionamiento es mucho más rápido en...
We can show you the real-time prototype of Rita. So
Yeah.
this is a prototype, is what it is, but we can make some, let me just...
That's one out of MATLAB. That's the new one.
Yeah, this is the new one in C++. So this is a electrical measurement that I made. Okay, so we can see that if I apply, for example, 1 millisecond of delay, doesn't work. Why? Sorry, because I'm sending it to the wrong place probably. Okay. Second. Okay, it's here. Okay, it's a refresh. Okay, so you can see that this works quickly, the real-time version. Okay, so if I put game, this go. If I reverse my polarity, it goes. Sorry. Yes, polarity is reversed. Here is a problem with the face, but the impulse is reversed. So the new version in C++ will be much faster, and everything that you saw in that we see, you can see in Rita 2.4 will be made in C++. So don't
Okay.
have that lag, let's say.
Okay.
Okay. Thanks.
Yeah.
It's the most powerful
one
software
more
that I've
question,
seen
please.
doing this.
Will
Sorry,
be
Michael.
there ability to see levels from the engines?
Yes, sorry. I forgot that. Thanks. Here, down here, we have a monitor level. Okay. So let's say that I will make two quickly electrical measurements. Okay. So let's go. So it's will keep the highest value, I think. So if I go here, I can, my computer, sorry. Okay, now it's more close to number one and number two. So it's the 8 engines. Okay, so I will turn up my gain. Okay, so you will see that clipped. Okay, in red. I will, sorry, let me just take it off. So we have 3 colors and we have the dB full scale value peak. Okay. So this is the metering now that we have, just to see what we have to do. I have an analog sound card, so I have to go by steps if I want to put the same value. But
it's just a meter bridge. Let's say it's a meter bridge.
Yeah, it's a meter, so it's what it is. So, but it's here, okay?
You forget about talking about the house and the grabber and the home, the small icons inside the window.
These ones here, okay. So data tip, home is home, so resets the position of the plot, the graph on the plot. So resets. I think that I'm doing nothing. So okay, resets. The hand is to move the graph as I have done. So move the graph, the zoom in and zoom out. And we can make just one click, okay, to zoom in, or we can, for example, pick a portion and zoom that portion. So if we click at home, that goes to the initial state.
When in the zoom tool, can I do alt to zoom out, like Pro Tools? Can I alterate the commands? You know what I'm saying?
I don't know. Let's try. No.
Okay.
Yes, you can.
Yes.
Sorry.
No, that I'm just following. I'm gonna come to class tomorrow anyway. But yeah.
No. Let me just see one thing. Sorry, my computer. 1, 2. Okay. Okay, zoom out. No. I don't think so, but you can try. I'm trying with Command and Shift, but you have the tool here. I don't know. I have to try it.
Oh, perfect. It's super, super powerful.
Okay.
Before you close, thank you for everything. Pepe quedó perfecto. It's beautiful, bro. It's hermoso les quedó. Thank you, guys.
So I don't know if you have more questions.
Just a little question, Nuno.
Yes.
It's actually a doubt if this exists already in the software. Is there a shortcut for to configure all the references in all the engines at once?
Sorry, let me. So in the engines,
Yes.
all the reference here to be the same.
Yeah, we got to change them one by one, right?
Yes.
At the moment.
Yes. At the moment, yes.
Yes,
Okay.
Cesar, we talk about this. We are working on this, an option to choose one number and apply all.
Yeah, that will be awesome. Also, maybe selecting, for example, 4 channels, and then making a change, and then the next 4 and making another change for whatever reason.
Yeah, we want to work on this.
Perfect.
Okay. So if you don't have more questions, I have to thank you a lot. I hope that you can see what is possible to make now with Rita 2.4. This is an early adopter version, so it's a really new product or approach, but we want to make it a valid tool. So thanks a lot for being here, and we can you can just 2 things to know. We have Get Audio Solutions page where you can free download our prediction software, Submap, that you can use, and some more. Let me just pick this down. So in apps, you have some applications that you can free download. An SPL meter, okay, that is that one. I can show you. It's completely free. Submap you can make download, and the loudspeakers balloon that contains the speakers that are made now for using with Submap. Low beam control, that is an application to calculate all pass filters to control low beam on arrays. And this is Rita SPL meter. So you can use it, you can calibrate, you can see.
No, a question.
Yes.
In the website, Rite SPL Meter, tradúcelo, aún no está. Estamos trabajando en el de Windows para colgarlo.
Só está o de Mac, é isso?
No está en ninguém.
Ok.
Todavía, estará pronto.
Sí. In this moment, there are not.
There are all version. That
Yes.
new version.
Yes, this version is a new one. With this one is a new one with the same compiler of Rita 2.4. Okay, and in the website there is an older version that is the same. Okay, but works with the old compiler. Okay, so but it's the same. The functions are the same. Okay, so just to see it, you can free download. The low beam control is here. I can show you too. It will be upgraded very soon, and it will So this is the calculator you can use. We have some videos explaining it, and sorry, we'll have probably some sort of more stuff coming out. This is completely new. Okay, it's a plugin. We are working on some plugins to help us to make things. Okay, so this is the virtual DSP from Rita in a VST version. Okay, you can use in real time. Okay, so if you want to follow us, we have the Rita Analyzer page or Rita Users page. So Rita Analyzer on Facebook. So Rita Analyzer page. My computer is dying, sorry. So Rita Analyzer page. And we have two Rita users. Okay.
Nuno, where is going to be the folder, or where is the folder that I can go in and steal some of the measurements you have from the past so I can have some exercises? Or I already have some with installation, don't I?
I can tell you that I don't have measurements. I'm very crazy guy. So
I have speakers in my house. I can just make me some.
Yes, but maybe I can find someone and I can send you. So
I can do what you just did. I can just flip.
But I can send you. I can send you. No problem. So
Gracias.
Send me just a messenger, Facebook Messenger, Nuno Coelho.
On it.
Nuno Coelho, and send me a message just to remember me. Okay. So this is me in another life.
Nuno?
See?
With the current available version of the mapping software, I always confuse them.
Yes, submap. Yes.
Submap. Sorry. The impulses can be exported and imported, right?
Yes.
So you could probably do some exercises, doing some simulations first, and then
sorry, them. I don't refer that, but you can make.
No, if you want, I can do this from. Perdón, hablo en español.
Sí.
La pregunta es probar cómo importar y exportar de Submap. Esa es la.
Sí. Pues estaban a preguntar si daba para fazer, sí.
Sí, lo hago en un momento que, como el mío va más rápido, dame un segundo, lo abro.
Voy a parar, sí. E podemos importar do Submap, fazer predições. We can make predictions in Submap, put microphones, and export as a WAV file, so as an impulse, and just use the load function on Rita to import that, okay? And make the adjustments. And then decide what to do and go to the Submap virtual processors and put the information of the adjustment, okay? And we can too import from MapXT and Map3D direct to Rita. So if you export your measurements on MapXT or Map3D in the impulse window, okay, in the impulse window without syncing, okay, you can load the Excel file on Rita. One important thing is that Rita, Meyer Sound normalize the impulse, okay? So you will lose the amplitude correct value if you go to the sides or from a measurement. Okay, but for find the delay time between in a side view from a sub and a PA,
you can work with the time. You just lose the reference between levels. So
levels,
everything's
yes.
on the top,
Yes.
but time wise, frequency wise,
we lose the reference, the amplitude reference. Okay, because the impulses are normalized on map.
Nuno,
Please,
si me traduces, que
Sí.
seguro que lo harás mejor. Un ejemplo muy sencillo: sistema principal contra sub.
Yes, in submap, one system of PA versus sub, we pick a microphone.
Ok, un ejemplo, podemos simular un ejemplo real de cómo haríamos una medición por promedios en Rita, simulándolo en submap. Y así podemos ver la idea del promedio y cómo saber qué pasa en cada micrófono con ese promedio.
Yes, we can take that idea of averages in submap. So we can put 4 microphones, take the measurements in 4 positions, okay, and load the 4 microphones to Rita and calculate the average on Rita. Okay.
Okay. Go to.
We just use the function save that is in front of the microphone's position, okay, X and Y. So when you use save, when you click save, you are saving the impulse, the wave file, okay?
Okay, here we have the sweep. We play the sweep.
Yep.
3B. Here there are
transfer functions from the 4 microphones.
Okay. The next, we now are working in a new version of SumMap. I think probably will be for 6-8 months. The idea is the SumMap is working together with Rita. You can do export to Rita and directly go the input response from the memory bank of Rita. Now, one-on-one. Save, microphone 1. It's a real measurement. We play a sweep. We take the measurement.
Yeah, just one sweep, and the 4 microphones have their responses.
Okay. Now we play a sweep. A subwoofer. Okay, here is the response. And now we can load external input response from Rita. Load.
And we can choose the 4 or the 8 in this case if you want.
Okay, P1, P2, P3, P4. An important thing, in SumMap, we can listen our optimization, but this reason, normally when we import the input response from SumMap to Rita, the level is too low. No problem, we have a DSP.
So for protection, the response is lower in level, okay? It's low in level. So we can make a gain of 20, for example, in all of the channels, and we maintain our relative amplitude.
How did Pepe knew that it was really loud? By looking at the graph, or he knew because
we know that the trace will appear with a low level. Okay, it's always.
So now I know. Every time that I come from one to the other, bring it down. Okay.
Yeah.
Yeah, the problem is that you can listen. You click on your microphone and you can listen what happened in your system. You can put music
On SubMap.
on
On
some map.
SubMap, we can listen the microphone position. Okay, so if we put a file, SubMap have a player, so you choose, for example, play 20 seconds of this song, this file, okay, and you click on a microphone, you
in a
are
button.
listening as you are there. Okay.
What happened in the microphone?
What
But
is
the
happening
po-
on microphone with
but
the
the-
EQ and whatever.
But the problem is that how is a WAV file if the WAV file is more than one or more minus one, the file don't work, and then submap go down the input response for to protect.
Yes, it's
For
for
this
protect.
reason, we need to do gain when to export to reader. Now here we have the measurements. Okay, I can save my bank, export all, take the measurement, and after think that happens. What happens? Okay, export all. Here I have P1, P2, P3, and P4. Okay. Now I import. Sorry, I import the subs. And can export. Sorry.
Why is he
Okay.
importing and then exporting again, Nuno?
To have it in the memories.
Because he
Okay.
was a snapshot. He came as a picture snapshot and then he brought it back. That's why?
Because it's when you import, it's just on the buffer.
It's in the buffer.
Oh, you're right. Okay.
Okay, let's say.
Okay, and now we can do save a picture or a input response. And now for this example, I think it's better to export the input response because after the optimization, we can know what is happening in every mic position. This is an example. Okay, a real measurement. Play a sweep. Yes, shoot. Sync all. My average. Sorry. My average. Export my average.
Because it's just in the buffer.
Just is in the buffer. Now it's in the buffer. I can do a save. I can save the input response. I prefer for this moment to save the input response. Okay, this is my input response. This is my difference between every microphone.
This is the average of PA, I think, Pepe. Average PA.
See, okay, but this time in delay
Yes.
in DSP is the difference between
Microphones.
Microphone
positions.
The last microphone is 172 milliseconds after to microphone one. Is an information. Okay, and now I have all microphones synchronized, but only the synchronized play a sweep. I do this importing and do the average. This is my average. Okay, I can see this here. Sorry. I can see here my average. Okay, save, export my average. Now I can do the optimization.
The name of the other average is PA. Don't.
Okay, sorry. Average
Just to not
main.
confusing. Yeah.
Okay,
First one is
and
main,
now
yeah.
import. I know it's the same. I do something wrong. Okay, no problem. I have my measurement here. To do this.
Cinco.
Syncol, okay. Average. Export my average.
Ahí trajo todos los tops, he put them together, he exported, and he saved it as one.
Sí,
Y luego de nuevo con los subs, right?
correcto. In a real measurement, we play a sweep, take the measurement from the main system, save input response, and now play a sweep in subwoofer systems and take the average. And now we can do the measurement only with the average input response. Okay, it's okay. Average. And now, sorry.
It's PA, yeah.
You see,
Why is he not
Wait.
using the other 4? Because there's no need to fill everything because he's gonna go back to averaging, right?
We use the first, the 4 for the PA, and then we substitute on the DSP on the same places the 4 from the subs, and make an average of PA and an average of subs.
Yeah,
Okay.
he's just like
Sorry, I
briefly.
believe also, I don't know if David was thinking about why is Pepe not using the DSP2 with the DSP channels 5 through 8 for this. And I believe that is because when you sync all, David, I think you're syncing 1 through 8. And when you're averaging all, you're averaging 1 through 8.
No, the question is that when Pep do sync all, okay, they sync for the main system 1 through 4, right? And then you have to use for the 4 sub measurements the same delays that
Okay.
are on the DSPs.
Cesar,
Yeah,
look this. Look this. I think it's better to understand this. Sorry. Sorry, I delete this. And import. This is all my measurements. Okay, we have 4 positions. We want to obtain the impulse average response. We have 2 options for to do an average. We can synchronize all microphones with a different time of peak noise, or another option. Our option is we want to obtain the average input response. What are doing Rita? When we click sync all, look where is the last input response, and then put all them in the same position. Look. And now I can to obtain the average of the input response. And this time, the time in the DSP channel is the synchronized time, is the delay that has every microphone. And now I can obtain an average of the input response here. This is my average. And I can to save only the input response of the measurement. Export. and this is average main. Okay, and now I have all microphones synchronized from main systems. We only need to do this: the synchronize. All microphones are synchronized between from the main system, and now play a sweep in the subwoofers. I importing this in the same channels. Sorry.
Upload, but yeah.
This is the response of my sub.
Okay. There's a trick here. Aquí hay un truco. Cuando import, you don't delete. That's a new thing.
You don't delete. You don't delete.
When you import, you don't delete.
You just bring the subs measurements to the same places, because the position one from the main is the same position from the sub.
Sí. O sea, that makes perfect sense. It's just new for me that when you import, you don't erase.
Don't erase.
Okay, eso es
don't
importante.
Erase and
See, okay, it's a better question. It's a good question. Yeah, we need to think how to do a continuous time measurement. We put one microphone, two microphones, three microphones, four microphones, and synchronize every microphone between a peak noise. And after, when all microphones are synchronized, we don't synchronize the subwoofer's energy.
This is because we're still using the same FFT measurement that we use the high piece of the frequency to get the time, right? That's because of the same concept. We're still measuring with a high piece. Okay,
now I only do the average. I have the average, sport, my average.
Sorry, Pep, we don't delete the delays, and we don't synchronize, okay?
So we don't synchronize
anything.
Just
swap the 4 main measurements for the 4 subwoofer measurements on the same places.
I can explain this quickly, and after this example. Okay, sport. I have all information that I need. Okay.
Just remember, Pepe, that we have another is here. Emilio.
Emilio begin now a Portuguese.
Okay, it's in another place?
Sí, it's in another place.
Okay.
And now I have the impulse response and the impulse response of my sub. And now I do the optimization. Fine. I can see that the subwoofer
is delayed.
Is delayed between main system. If I am doing this in a continuous time, I need to resynchronize all microphones from the subwoofers and then obtain the high frequency. But here we can do this. Okay. I synchronize between subwoofers and can do the optimization. Okay, I can see this probably polarity. Sorry, for polarity and 6, more or less. This is my optimization. But an important thing is the optimization in an average. This is not the response in the microphone 1, in the microphone 2, in the microphone 3, in the microphone 4. There are different distance between every microphone. This is more near of the main, como es lejos, far of subwoofer. This is near of subwoofer, but far of main system. But this is one possibility. I can use a high pass filter. I can use a all pass filter. We can we can choose no put delay and put an all pass filter in second order, probably in
100.
I don't, sorry, moment. I need to. I was here, okay.
Se te cambió el orden. Está en uno.
Dos, probably 80, 85, more or less. I have the optimization with all pass. I can do this in submap, polarity and all pass 1 second on main system. Main system 1 second, all pass. Delay 1 and all pass second order 85 and polarity to the sub. It's a simulation of a real world. It's a big plane. I need a lot of calculus. Here, this is my response. Okay. The average in this position goes ever from first microphone and second microphone. Look this. This is my optimization. Okay. What happened in a microphone one? I don't need to measure other time. I have the information. What happened in microphone one? Import microphone one. This is a DSP. The impulse is processing in the DSP, and this is my subwoofer response. What is the response in the microphone one? Okay, is this? I have zoom, perfect. Okay, what is the response in the microphone two? Sorry. Here, a little bit, the subwoofer was delayed, but I have zoom, okay? But what happened in the microphone 3? Here, microphone 3 has a problem, and microphone 4 has a problem. Okay, here, my sub is delayed between is delayed
From the main.
with the main. Okay, this is my zoom. Okay, I have a little problem. What happened in the microphone 4? I have a problem. And now this is an option for to use zoom map and Rita or a simulation or a real world. And I can see that probably is better option to choose microphone 3 for to do the alignment. And no problem, I have the information and I don't need to do another measurement. Okay, I don't like this optimization. No problem. Clear. And now I have microphone 3. This is my response. I need to put delay of the main system. I can synchronize from here, from subwoofer. I need probably 10 milliseconds, 11 milliseconds, or 6 milliseconds, and all pass. Okay, this is now my response in microphone 3. What happened in microphone 4? This is what happened in microphone 4.
Why are you measuring against subwoofer 4 and not subwoofer 1? Because it's the measure of the subwoofer in the last microphone. Forget about it. Sorry.
Tradúceme en uno.
O sea, ¿por qué medías el 1 contra el 1 y el 4 contra el 4? Pero es porque estás midiendo en la posición 4, no es el subwoofer 4.
Sí, háblalo en inglés para las personas inglesas, Nuno.
Sí, it's asking why you are using the position one
why
against...
one? I was thinking, why position 4 to subwoofer 4? Is subwoofer 4?
No.
Together,
It's position. It's main in position 4 and
position.
subwoofer in position 4, not the number of the subwoofer.
See, one more question. Every time you select in engine 1, speaker 1, then speaker 2, every time you touch find, you're selecting the one you wanna use, like the 0, like the reference.
The reference, yes.
Okay.
It's the reference. So in this case, if you make synchronization with the main, okay, we see that the subwoofer is delayed. So in a real world with a continuous noise, we have to remeasure and resynchronize. Here, no, we just synchronize with the subs and apply delay to the main, okay? And then take off the synchronization and synchronize with the main, and everything is okay.
This time we can graphic the future, for say something. We can see faster times.
Yes.
Sort of, yes.
The thing is that you can make lots of experiments. So and try and be more agile to tweak the things and to think and to read plots. I think is the greatest thing on Rita.
Okay,
so go, Pepe.
And now we can see the difference between optimizing between microphone 1 and 2 or microphone 3. Okay, here you can see how the energy goes from microphone 3 position. Okay.
Oh, you set up the system over there.
Yes.
Bajó el lóbulo. He moved up the lóbulo.
In this case, the lóbulo goes up. So
the first option was to use more or less 1 millisecond.
Yes.
But this is the result using an average, but this average is a 4 different positions that has a lot of difference of time. That in a asymmetrical situation, this person is near of main system and this person is near of the sub. And then we can do perfect for everybody. We need to take a decision. But the idea that to use an average and to take the input response is this. I can compare where is the best position without to do noise. I have the information. If I have the information, I can think what must to do for the best option. This is the idea. For this reason, we prefer or we use input response from the measurements, because we want to import and process every time all measurements. Okay, I think it's a long way today. Si quieres despedir, Nuno.
Hey, thanks one more time for being here with us, and follow us on Rita Analyzer and Rita Users. And if you have doubts, please feel free to talk with us. Thanks a lot.
Gracias a todos y estamos en contacto.
Thank you. I'll see you tomorrow.
Okay.
Gracias.
See you.
Pepe.
Vale, Nuno, pues cuando termine me avisas y lo
Interromper gravação. Interromper
No,
gravação.
cuando cierras creo que ya la guarda, ¿eh?
Ok.
Creo que cuando tú haces cerrar.
Sim. Vou até o Zoom de Emílio.
Vale, sí. Yo voy a jantar y después voy para el Zoom de Emilio. Obrigado, Emilio. Muito
Até
bem.
já,
Muito
um
obrigado.
abraço,
Até já.
Até já.